Bismillahirrahmanirrahim. Assalamu alaikum. This is Shafqatullah, Engineer Shafqatullah, along with my group mate, Engineer Talha Abdur Rahman, and we are going to demonstrate about our FIP project video. And this is our project name is Automatic Coil Winding Machine using Arduino, and it is supervised by Engineer Ghulam Akbar and co-supervised by Engineer Veer Bahan. And also coming to the agenda, what we are going to discuss in this video. First of all, introduction, motivation, problem statement, literature review, aims and objective, methodology, results and discussion, conclusion, final, future recommendation, references. And coming to the next, let us go to the introduction. What is coil winding machine? Coil winding machine is the machine that is used to wind coils on the transformer, induction motors, and chokes. And this automatic coil winding machine consists of two stepper motors and other hardware infrastructure for the proper usage of winding. It is a fully programmable platform. So, and it has facility to select number of turns for the coil. As we are going to elaborate that our machine is fully automated. So here we have to give the user input. So for the user input, we have placed the LCD and the keypad to enter the number of turns for the coil. Also coming to the next, what are the attractive feature of automatic coil winding machine? Why this is mm, better than the manual coil winding machine and semi-automatic coil winding machine? Because it is in the tension in the wire can be controlled by using this coil winding machine. Is a basic Tension is a basic part which plays a major role in the coil winding machine. If the tension is not fully controlled, then there will be no efficiency, and this will cause some damage. Then this coil winding machine is efficient and economical for small scale users. It also it is very efficient and very economical for small scale user. It has less cost than the other coil winding machines. And coming to the motivation, what are the motivation behind this? As you know, world is moving towards clean energy, and demand of electrical vehicles are going up upside. So we have to wound different parts of the vehicles and cars, electrical vehicles. So we can wound that through it. And automatic coil winding machine for small industries and domestic user. But automatic coil winding machine is basically used in the large industries, and for the it is not for the small scale and domestic user. So we are going to made a coil winding machine which is for small scale users and domestic users to reduce human error and to increase efficiency. We see in our daily life that mm, there are electrician which are winding coil through hand. So there will be chances of human error. So we are going to reduce it by using motors, and by doing that, its efficiency will be increased. Increase in demand of automatic coil winding machine. So in the future, you know, the world is moving towards automation. So there will be a heavy demand of automatic coil winding machine in the near future. Problem statement. What is our problem statement? What's the reason behind that? Well, unavailability of automatic coil winding machine for small scale user. As I have discussed, that automatic coil winding machine was not for the small scale user because it's used in the large industry. Small scale user use manual coil winding machine. So for the efficiency, to get efficiency, we have to made this. And for the small scale user, due to time consuming and inaccuracy and outcome, manual coil winding machine is hectic. A manual coil winding machine, which we saw in our daily life, that it is time consuming, very, very much time consuming and inaccurate, and its efficiency is not so good. Tension in the wire and air gaps are the major parts which are going to work, which we are going to work on this. And the next literature review, in we have research, we have studied different research paper for this. In first research paper, V.S. Zhang has mentioned the quality of the motor and speed regulation of the automatic coil winding machine by winding of the motor coil, which is not tight, which result low short circuit resistance. So it is basically upon the speed, and in the next passage went through mention in a research paper that coil winding machine is very expensive and complex, and that is for large scale user. So for small scale user, we have to overcome, and speed of motor must not change with cause have. So this is because basically the speed of this is basically describe the speed of the motor. And in the next, Parjal Vaskar has discussed the tension in the coil. Tension is the main part, as I have told you that tension in the coil is a major part in the winding. So the tension must be controlled in that. And in the last research paper, Norman Borchardt has talked about the automation and air gaps, removal of air gaps. If there will be air gap in it, so if its efficiency will be low, and due to low efficiency, the accuracy will not achieve fully. And what are the aims and objectives? Our first aim and objective was to design and build a coil winding machine that has a small scale and a lower cost. So we have to build a coil winding machine that was mm, for small scale user and lower cost. So we have achieved this objective, and also the other one, to create and write code for movement of stepper motor and more, which can be controlled by using Arduino Uno at Mega 3 from Arduino ID. We have to write a code, programming code through Arduino to control the stepper motor, because the stepper motor can be controlled by using some programming. So we have made that code by ourselves by using the different loops and logics, and to increase the efficiency of the transformer and motor by winding the coil tightly. And because we are going to increase the tension in the coil and the air gaps, removal of air gaps, so the efficiency of the transformer and motor will increase when we wind the coil tightly. And to be a learning tool for student to wind a small transformer, and in are going ongoing student, which are our juniors, are can also wind the transformers and motors and all other equipment which are going to wound. And we have achieved that as well. We have achieved all the aims and objective. And next, over to my group mate Talha Abdur Rahman.
Assalamu alaikum. Now I am Talha Abdur Rahman, and I will move towards my part of presentation, that is after my group mate discuss about different aims and objectives and things that we are going to be used in automatic coil winding machines. Now I will discuss about the methodology that I am going to use. So in the methodology, we first of all, we have to gather information about our project, that is literature review. Then after that, we will design an intra coil winding machine using SolidWorks software. And that is the hardware part of our project. So we will design our hardware part on SolidWorks design. Then we have to decide the material and types of motors and software to run the motor. Software in the motors, types of motor, we use stepper motors, and the software that we use for coding is Arduino. So after that, we will hardware fabrication. We will fabricate all the parts of hardware. Then after that, we develop Arduino programming and move to stepper motor accordingly. After that, build coil winding machine. In the next step is coil building of the coil winding machine. Then we will test that machine is working properly or not. If it not work properly, we will troubleshoot it and again build coil winding machine with new some small changes. So after that, if it will be successful, then it will be the end of our project. In this hardware, we also write the hardware design. We are using SolidWorks and implement hardware. Then practical model until of coil mining machine and doing programming using Arduino. We observe output and improve the efficiency if it is needed. Then we will update the hardware, and after that results, this is our result, and it will be the end of our project. Now we are moving towards the main hardware part. This is our main hardware part that it is looking like. So the main hardware is designed on SolidWorks software. Components are also designed of designing of automatic coil winding machine is on SolidWorks. So that's why these are the parts which is based in bobbin support. This is the bobbin support part, and the dimensions of that part is shown where which we are used for the bobbin, and that is circular part will show that it is for the movement of the bobbin. As we use different bobbins for the winding. For the transformer has different bobbins according to its rating. So that's why we on the base part we also use the movable part for the bobbin. Then after that, we have designed the nozzle panel and motor support part. Motor support part is used to support the motor because the motor has some weight, and also when it moves, this will get vibration. So for that, we use motor support part to minimize its vibration and effect on hardware. The other part is nozzle panel, which is used for the to nozzle to move horizontally and correctly move off the wire on the bobbin. Then these are the nozzle part and roller. Nozzle is used to come out with wire air and mount it on a bobbin. The roller is used to only mount one wire at a time. Not it will overcome the bundling of problems of the wire. Then coming towards the electrical schematics, we have designed the electrical schematic on Eagle PCB board, and that is the printed board of PCB that is done in our university IBA in the Fab Lab. So we have implemented at printed board circuit. In this part we use different and to headers. It is female headers for the components. In this part, these two are used for the motor driver. This is used for keypad. This is used for the motors to input 4 wires of motor, and this is I2C module, which is used with LCD to print out our objectives. Now comes towards the code that we used in our project. In the code, this is the flow chart of our code. First of all, we have to take input from the user, that is number of turns and length of the bobbin on which we wanted to be wound on which we wanted to wound the wire. So these are input from the user. These are input through keypad and print out on the LCD. Then after that, it will go to Arduino controller, which will decide its motion, how much it will move, and what are the factors that are going to be used in this thing. So for that, we have to come through that. For one step of a stepper motor, it will cover around 1.125 meter distance. So that's why we use this for rotation, and then we multiply this part with 0.73 into steps per revolution. Steps per revolution is 200 steps for a stepper motor. That it is will use 200 steps, and then 0.73 multiply with it. The other part is this is used for one motor, that is for the bobbin rotation. The other motor that is used for horizontal movement. In that case, we use number of turns and other thing to multiply with it. Then it will go to controller Arduino, and it will decide to move the motor M1, which rotate the bobbin, and other motor that is M2, which will horizontally move the roller. So this is our main code which we are going to be used in our project. And these are the outcomes of our project. What are the outcomes? We have come. We have done 3 tests to show the efficiency of project. First is result for thread use. This is first of all we use thread to show that our machine is working correct or not. So first test was on thread, and its result is shown in figure 12, and we have seen from the figure that the result is satisfactory and the binding is done properly on that part. After that, we have done the result outcome on second test on thick wire, that is as are the gauge of 28. So second test was on wire of gauge 28, and its result is shown in the figure. This will show that we have the winding gap between the wiring is very little. It's not being seen from the picture. So it is much satisfactory result we have obtained from our machine. After that, we have the third test, which is on the wire of gauge 24. This is a thin wire that we used for that purpose, and we can see from the figure that there is no, didn't see any gap between the wires, and the tension is also high because we are using the nozzle part, and the strength we can see that the wire is very much stretched. So that's why the tension in the coil is required one that we have to be needed for the wire mounting. After that, this is our final output on which part that we concluded our project. So as we can see that at this is much improved part, and it is efficient, and the gap between in wire is not that much, and the output is satisfactory according to our and the result is satisfactory. So this is our final project video. So first of all in this project, we have LCD that will print out the outputs. Then we input the data, which is number of turns and the length of the bobbin that we are entering. So it will print out that the working machine is that the coil is now wounding on the bobbin. So we can see from that video the working out project. After that, we come to the conclusion of project. This machine is designed by using SolidWorks software, and programming is done by Arduino. In this we use for hardware design, we use SolidWorks, and for programming we use Arduino. So this model is much improved and have high efficiency. We can see from the output picture that the result is improved and efficient efficient, and it can be useful for the lab purpose and other small scale products. It's very similar to that of actual mining machine in industry. So the infrastructure that we use and the layout of machine is very similar to the machines that are already used in industry for the winding of for heavy winding purpose. Then keyboard is used in this machine to enter number of steps and to show that on screen. And we use I2C module for module and LCD. So this machine is automated and results are much improved than semi and other coil winding machine. So the semi-automatic coil winding machine or manual coil winding machine come to different errors. So we discovered that this machine has much satisfactory result than these two machines. To come toward the future recommendations, as we already discussed that the world is moving toward green energy and electrical vehicles, so this will improve improved technology is very useful for machines due to electrical vehicles. It can also be improved by using different sensors to improve its efficiency. As we have input the data from user, take data from user as number of turns and the length of bobbin. So if we use sensor, then there is no need to input tech data from the user. So it automatically sense that and will mount on it. So that's why, other than the Arduino programming, we can also use PLC programming for that, which is commonly used in industries. Electrical motors and electric cars are major growth in this machine. So in this machine, we can be used for electrical motors, etc. The rise in demand of energy in emerging world. There is also, as energy is demand is increasing, so this machine will be used there for, they are also used there. So introduction of portable power devices and textile sectors are also the future of this machine. So this machine can be used as portable because it is smaller in size and light in weight, so that it can be used everywhere, and we can take it from here to there. So it is portable power device. The references that we used in this project, these four are the research paper that we come through in this project. This is first one is speed regulation, about speed regulation, and we have to maintain the speed speed of the motors to mount properly on the bobbin. The other one is design and development coil winding machine. The other third one is also about design and development of automatic coil winding machine. The fourth one is about the automatic production of innovative air gap, so between gap winding for lightweight electric machine. This is to this research paper is mainly about how to maintain the distance between the wire. So when there is a very small distance between the wire, then it will be more efficient and effective. The other three are that is the principle of winding machine. So we have to come through what are the different principle that are used for the windings, and then we also use Arduino official page as to use for the Arduino programming and other things for related to Arduino. And the last one is research paper is about the tension control of the coil wire that we are using in this project. So thank you so much for your attention. This is all about our project. Thank you so much.